When you think of storage vendors in the IT space these days, my guess is that the name Microsoft does not come to the forefront of your mind. For a very long period of time, Microsoft was the tool by which we created file servers, but most of us then took those file servers and attached them up to some production SAN. In smaller environments, we may have used locally attached disks, but for the most part, a storage vendor and Microsoft were not two concepts that were together in our minds. Well, recent advancements in technologies in Windows itself and the protocols that Windows sits on top of actually are beginning to make Windows or Microsoft kind of a compelling runner in this race for who might be your storage vendor. In this nugget, we're going to talk about some of these new technologies that exist in 2012, in the Server 2012 and 2012 R2. These are things like tiered storage. Tiered storage is a technology that's been around in the hardware storage vendor space for a period of time now. And it is literally the idea of tiering out different classes of storage so that one class of storage, high speed storage like SSDs, can sit on top of lower speed but lower cost storage like regular spinning hard drives so that you have all the benefits of fast drives but without all the extra cost. These days you can go and buy an SSD for a couple of $100, but these are not the type of enterprise class SSDs that you want to put in a data center. And so, because of this period that we're in, where regular hard drives are so much less expensive than SSDs, concepts like tiered storage give you all the benefits with a minimum of cost. Keeping those storage costs low is also challenging when you got people that are constantly adding new documents all over your storage locations. And if your file servers are anything like my file servers, there are probably multiple different copies of data that exist somewhere inside of that very large file structure. And so technologies like data duplication give you the ability to automatically just look for areas where individual bite-sized chunks of data are similar and then remove them, reapply pointers to that data so that we can just simply shrink the amount of size that we have to keep under management and actually continue to pay for. In an era where data is constantly growing, techniques like data deduplication are becoming ever more important for us to just simply keep the costs down. These technologies also extend themselves into things like thin provisioning. Now, when storage is something that doesn't cost you anything at all, being able to thick provision your virtual disks and thick provision out potentially even your virtual machine virtual disks is something that you don't care about. But very few of us these days have an unlimited storage budget. Anytime we're dealing with thin provisioning, we have to be very careful about making sure to monitor our disk configurations and utilization to make sure that the multiple virtual disks that we've created are not going to end up extending past the actual physical size of the disk. Trim is also a technology that is commonly associated with SSDs, and trim is, it's actually one of those technologies that's kind of hard to locate as you poke around on the internet. Trim is essentially a command that we can offer onto a storage type or a SSD type disk that can help maintain the performance of those SSD disks over time. And there's really one or two different PowerShell commands that I want you to be aware of that are specific to this exam that are important for helping you understand where you can configure trim. We are in this nugget also going to talk about some of the more enterprise type storage things like configuring iSCSI and in the ISNS service. Now, iSCSI is a mechanism for you to create and provision storage across your network. And the cool part about iSCSI is that unlike Fibre Channel, when iSCSI, as long as you have an existing network, which you already do, well, then you have the ability to carry that information from server out to storage somewhere. One of the neat things about iSCSI storage is that it becomes possible for you to take a Windows server, attach it up to one or more physical disks, and then from that location use the Windows server as an iSCSI target for other servers to connect to. So here's another server up here, another Windows server with multiple connections through iSCSI. The neat part here is the combination of Microsoft's technologies for local disks with Microsoft's technology for remote style disks. So I can, with a Windows server today, hook it up to whatever local storage it may have, and then provision and extend that storage out over the network to other Windows servers as I see fit. Keeping all of that technology in within the Windows stack kind of helps me when it comes time for troubleshooting because I don't have to go to multiple vendors to figure out why something's going wrong. In this nugget, we're going to talk about the combination of storage spaces, which is Microsoft's local storage technology, with iSCSI, its remote storage technology. You can kind of think of the difference between storage spaces and iSCSI as splitting your Windows server between the top half and the bottom half. Everything here that has to do with the local storage for your file server is going to be something that exists in storage spaces. And everything that exists above this dividing line will be something that's provisioned out over the network through iSCSI. So thinking again of a Windows machine as a file server that's not just a file server for file shares, but one for all kinds of data is what's going to make the difference here between your old way of considering Windows and your new way of considering Windows as a storage provider. Now, ISNS down here is one mechanism. Again, we'll talk about this here in just a second. There's very little about ISNS that you have to know for the exam, but I just want to show you kind of the introductory the pieces for how to get it installed and initially configured. ISNS is really essentially like a DHCP server for iSCSI. And that's the main thing that I think you should be aware of at this point. There's a mechanism for you to much more easily connect from your Windows servers up here to your Windows storage servers down here. And we have one kind of weird topic that got added here to this objective domain, and that's being able to manage server free space using features on demand. And I'll talk about this here in a second, but essentially this is a way for you to reduce the amount of storage that's required for Windows to operate at the C drive, the system drive that Windows uses, by just simply eliminating the features when they're not being available, pointing them to remote locations. So here we are back in our demo environment. This is the same environment we've been using for the entire series thus far. Only one difference, if you're following along at home, between the last nugget and this nugget is that the variety of domain controllers that we've been working with up until this point, I've kind of shut them all down except for the main one, Denver DC1, just so that I had enough resources here in this virtual environment to support the variety of additional virtual machines that we'll be working with. So if you're following along at home, feel free to shut the rest of them down and keep that Denver DC1 up, because that's the one we're going to be using for the remainder of this series. Now, I've built a server here called file1.company.pri. Regular file server running Windows Server 2012 R2 update, and it's got a static address here. Just a basic server at this point. I've also, with this server, installed a couple of roles and features here. I'm going to show you which ones I've installed. The installation of these roles and features is not terribly exciting. I mean, literally, you just kind of click through the interface here to see them install, so I didn't think you wanted to see that process. I've installed the file server. A little later, we'll be working with branch cache, so I've installed it. Data deduplication we'll be working with here in this nugget. FSRM a little later. iSCSI in this nugget. And then NFS and work folders we'll be working with a little later as well. So all of these have been installed here on this server, and no additional configuration has been made. I've also added a couple of different physical disks to this server to simulate how you would create storage spaces for the purposes of making it available over the internet or over the network. So let's assume this is my machine here, file 1. And I've attached to this machine 4 different disks, actually 5 different disks. 1, 2, 3, 4, and then 5. Now the reason for this is to be able to show you the variety of ways in which storage spaces can make disks available to a Windows server. 2 of these disks are going to be considered SSD disks. They are, I believe, 250 gigs in size each. The other 2 of these are going to be considered traditional spinning disks, and they are 500 gigs in size. And then I have a single disk over here that's just 1 terabyte in size. That's a regular SSD also. Now all of these, again, are running inside a VMware Workstation, so if you're playing along at home, it is just as simple as going to the VMware Workstation, the properties of the virtual machine, and adding in some more virtual disks. We will use these because I want to show you 2 different ways in which we can create storage spaces and then volumes that we will then extend via iSCSI. So I'll have this 1 terabyte storage here that I'll extend via iSCSI, and then I'm going to create a tiered storage space over here with these 4 disks so that I can show you how the SSD and spinning hard drive combination works with tiered storage. This is important because tiered storage requires you to have both SSD and traditional spinning disk. And in fact, I'll show you a little hack here that you can do. If your storage that gets provisioned into your server does not actually show up as the right type of storage, so that tiered storage will actually function. So let's take a look now at the File and Storage Services server here, and or console here, and then a look at the disks themselves that we've created. Right now we have a primordial pool here with all the available disks. So when you add disks to a Windows server, we create, I love the word, we create a primordial pool upon which we can then create additional storage pools out of. Now this primordial pool contains each of the 5 disks that I've literally plugged into this machine. But what's interesting, because we've just plugged these in at this point, there's nothing really to see here. The disks are considered read-only. There are no partitions. In fact, all the disks are offline at this point. This is exactly the configuration you would see if you powered on a Windows server and attached some disks and then just simply saw what was there. These disks are unformatted and ready to be pulled in to be used here in this system. For each of them, we need to bring the disk online. With that disk online, then we need to use those disks to create a storage space. So let's go ahead and bring these online and make them so that they're no longer read-only. And then with those disks online, we should be able to see them over here in storage pools as now available for us to create a storage space out of. So let's go here and create a storage pool. And we'll give this storage pool just a basic name, storage pool 1. You can get more creative with your file names if you wish. I'll choose next here, and we are going to associate this 1 terabyte disk here. Now we can with here determine whether or not if we're using multiple disks, so if I'm going to take 3 or 4 disks, more than 1 disk, and collect them together, whether or not I want to allocate this as a regular disk, so part of a mirror or part of a RAID array, or just as a hot spare. Okay, so useful here because it's nice to be able to set up a physical disk as a hot spare. One of the great benefits of storage spaces is now this capacity to support hot spares. I'm going to set this as automatic because I only got 1 disk in this location, and then choose Create to create the storage pool. Now anytime you're creating a storage pool, recognize that you're not actually creating anything like a volume just yet. The best metaphor for what we're talking about here between the differences of storage pools and virtual disks is that storage pools are sort of like empty spaces in which you can then create virtual disks, in which you then create volumes. So let me draw this out here because I think it's easier to kind of recognize. If you think of the sort of largest boundary here, that largest boundary is going to be the pool. Inside the pool, you can create 1 or more virtual disks. So 1 or more, this will be a virtual disk. And inside that virtual disk, you can then create 1 or more volumes. And it's on the volumes where the data goes. So we kind of have 3 different steps that we have to hop through in order for us to get to the point where I have a functioning file operating system or functioning file system and all the bits set up in place to begin storing data onto the storage. We've only accomplished the first of these at this point. You'll notice down here at the bottom that once we create that storage pool, we can then create a virtual disk on that storage pool. So created a storage pool, the next step is then to create a virtual disk out of it. But I don't want to go too quickly through these through these wizards because I want you to be aware of once I have this storage pool in place that I can create virtual disks, add them, delete the storage pool, or even view some of the properties here, like what the health is, what the different details are associated with the storage pool. This storage pool 1, as I said before, is just a single disk. So the things that we can accomplish with this storage pool are going to be relatively simple compared to what we would be able to accomplish with a storage pool that contains more than 1 disk. So rather than just kind of flip straight into the creation of virtual disks, let's actually create a second storage pool out of the disks that are remaining here in our primordial pool. I'll go back here to Tasks and create a storage pool and choose Next. And let's call this Storage Pool 2. Again, my really imaginative storage naming here today. I'm going to choose all 4 of these disks in this case. Now, when you create a tiered pool, okay, when we're creating tiered storage spaces here, recognize that it's important for us to create tiered storage spaces that have equivalent amounts of each disk type. So remember, I've got 4 different disks here. 1, 2, 3, 4. And each of these on top is an SSD, and each of these on the bottom is a spinning disk. If I'm going to have 2 SSDs, I got to have 2 spinning hard drives as well. So 2 and 2, 3 and 3, and so on and so on. So these 4 will create the pool that we need here, and then we'll choose Create. And at this point, let's go ahead and use this second pool, this second storage pool, to create the virtual disk that will later then have a volume. At this point, I'll choose to create the virtual disk, and I'm going to choose storage pool 2 here. It's got a capacity of 146 terabytes, and in this screen we can choose the name for the virtual disk we're going to create. So virtual disk 1. But well, wait a minute. I want to create storage tiers on this virtual disk. Aha! Here's where the labeling of these disks becomes really important. Now, I showed you the fact that we've got to have a couple of SSDs and a couple of spinning hard drives in order to create storage tiers. Well, there is a hard-coded requirement in here that the disks that we're using actually are SSD disks. Or are a split of SSD and regular spinning hard drives. But the problem that we have is that I've actually created 4 disks here, all 4 of which are actually SSDs. So there is a nifty little hack here. If you want to kind of play with this at home, I'm assuming you would not do this in production, but at least it gives you the ability to create both SSDs and regular spinning disks for the purposes of testing this out. Let's take a look at the disks that we have. So get physical disk, and I have those disks that are out there. Here are all 5 of the disks. They're showing here that they are not able to pool because they're already in a pool here at this point. They're okay, they're healthy. Here are the various sizes of them. And what I'm looking for is, let's see, where size, oops, not that one, FT, friendly name, comma, size, media type. That's what I'm looking for. Aha! So I need to change this media type from SSD to HDD. And I can do so by either querying on the individual physical disk, or I'm just going to query on the 2 disks that are here at the same size. In order to do that, I need to identify first the storage pool, and then grab those physical disks out of that storage pool. So let's do get storage pool, and I'm looking for pool 2 here. Get storage pool, and then storage pool 2. And out of that, I want to get the physical disk. Okay, there are the 4 physical disks. I want to get those physical disks where size equals, and then equal to this really long number here, 2676 303014 9632. I think that should give me 2 disks. Yep, those 2 disks. And then out of those 2 disks, I want to set their type. Set physical disk media type to a HDD. Cool. Let's see if I actually did it. All right. Oops. Nope. Let's go back here. There. And what do you know? I now have 2 disks that are of regular spinning disk type. So this is a nice use of PowerShell as an example to show you the variety of disk-based commands that you should be aware of for this exam. I'll show you some more of these disk-based commands when we get over to iSCSI, but these kind of commands are just ones that are fairly common to be seen on an exam. I would understand what these storage commands are and how they map to the different things we're talking about here inside of the GUI interface. All right, let's retry this. Let's retry this step again after refreshing things a time or two. Let me let this thing go and just validate that I have both SSD and spinning hard drives. All right. So let's create at this point a virtual disk. This virtual disk we will use again on the storage pool 2. And in this time, we can create storage tiers on the virtual disk. So let's call this virtual disk 2. I can use a keyboard this morning. So virtual disk 2 is our tiered or virtual disk that includes storage tiering. I can choose next here. For this, I need to create a mirror. I have only the option of using regular simple storage layout or a mirrored layout here. I can't actually use RAID array with these storage tiers. I can set up provisioning also. Notice that when you set up storage tiers with provisioning, you only have the option of using fixed provisioning. Now, this is important because when I create this virtual disk, it's going to go about creating an inordinately large virtual disk, right? One that is the full size of both of these 250 gig disks and both of the 500 gig disks as well. So if you're doing this at home, well, be aware that we're probably not going to want to hit the finish button here unless you have an incredibly large SSD that you want to create a big empty space on. I would be aware, remember, storage tiers require fixed disks. Now, for the different tiers that we're implementing here, obviously there is a faster tier and a standard tier, and I can specify what the size is going to be for these two disks. Because I'm creating a fixed disk, a very large fixed disk, let's protect ourselves here by putting, 5 gigs in the faster tier and then 5 gigs in the standard tier so that I have a total disk size of 10 gigabytes. Choose Next, choose Create, and now we're going about creating that virtual disk. Now it's at this point that I think it's worth kind of stopping and to reflecting just a bit on why would we want again to create tiered storage. Recall that when your users are working with their documents or dealing with data on a file server, there are going to be some files that are used a lot, SSD, and there are going to be a whole lot of files that aren't used all that often. And the files that are used a lot are the ones that the storage subsystem will automatically recognize and then elevate to SSD when it finds that they're being used a lot. When they fall out of regular use is when the storage subsystem can then demote them down to being a regular, back on regular spinning disks. The whole point of this being that the types of files that users are making use of more often will generally have a better performance than the ones that users are using less often. So that's why we're kind of creating this here, is so that we get a better performance without having to buy lots and lots of expensive SSDs. Now again, at this point, we haven't actually created anything that we can install a file system onto. We have to put a volume onto this virtual disk that we've created. So at this point, what we need to do is then create that volume and initialize that volume. I'll choose Next here and identify for file server 1, here's the virtual disk that I'm looking for. It is 10 gigs in size. I can choose Next. I'm going to use the full volume size here, 9.97 gigs. Choose Next again. I associate it with the drive letter E. Set up any file system settings. Here's NTFS, default, and then let's call this virtual disk 2, just so it is associated with my virtual disk. And then choosing the next tier is where I can determine whether or not I want to turn on data deduplication for this volume or not. Data deduplication isn't necessarily brand new in 2012 R2, but there is a new feature in 2012 R2, which is the ability to use it for Hyper-V. And a couple of caveats here with its use here in Hyper-V. The whole point of the data deduplication for Hyper-V volumes is based on the assumption that you're using some sort of separate file server as your storage area network for your Hyper-V machines. So if you want to use this VDI server version of data deduplication here in R2, you've got to have a separate machine than the machine that's running Hyper-V. In the original Windows 2012 instance, we had the ability to use it as a general purpose file server, or for general purpose file serving. And as you can imagine, the kinds of use are very different here. If I'm talking about general purpose files, a general purpose file server, I'm dealing with files and folders like Office documents. This is very different from how things would happen here as a VDI server, where I would be using very large VHDX files. Be cautious about implementing this because sometimes this data deduplication can have the untoward, unexpected fallout effect of impacting performance. Because you think about it, if I've got a bunch of people and a bunch of virtual machines that are all pointing to the same locations on disk, well, that could end up being a bottleneck for performance. So we're going to use this just as a general purpose file server for at this point. We'll later on talk about how we can implement it for VDI as we start getting into some of the more Hyper-V topics. But recognize that once I have the data deduplication role service installed, then I can instruct it to begin looking for duplicated files that happen to be sitting around for longer than a specific period of time. So 3 days in this case. The idea being that we want a machine, or we want a file to have a little bit of age on it before we start yanking around on it and creating duplicated copies, deduplicated copies. There are also going to be some file types that we don't want to touch because for some reason or another the application working with them just doesn't like it whenever we go about deduplicating those files, like EDV files and JRS files. I can add additional file extensions here if I want. Now, the majority of the work after the initial scan in deduplication happens in the background. And that's kind of the whole point behind deduplication, is that in the background it's constantly looking for files that it could potentially deduplicate. But there is the ability, in addition to setting a background schedule up here, of determining a period of time during the day or during the week where an additional throughput optimization is also run. This is going to be a resource-intensive activity. And so the idea here is that you run this optimization at normal priority using the full resources of the server at a period when you're probably not using this machine all that much, because it's going to just suck up more of your processor cycles and your disk IOPS in order to accomplish this pass. I can do the same thing for creating a second schedule as well for throughput optimization. So if I want to set one schedule during the evenings and another different schedule for the weekends, I can accomplish that here. This is nice because during those periods of low use, I can turn these things on and then get a little bit of extra effort in deduplicating the volume. I'll set this for OK now, and then choose Next, and then Confirm, and now we have a virtual disk that is incorporating storage tiers on top of a storage pool that has multiple disks that is being used with a volume that has data deduplication turned on. Whew, that's a lot of stacks there in order to get this thing operating. But recognize that these stacks of technologies, overlapping technologies, or layered technologies are necessary for us to be able to take a raw piece of disk, apply all of this cool storage virtualization technology on top of it, and then ultimately get us to the point where I have a disk volume here, an E drive, that I can literally make available to my users. This is now an E drive that's been exposed to this server so that the server can then make it available out through some network-based protocol like iSCSI. So a lot of steps indeed in getting us this far, but they're for a good reason, because I want to be able to separate out the activities that are done at the storage layer from the activities that are done at the layers on top. So here's my storage server, right? This is file 1. And I'm going through all these efforts here in connecting all these disks and doing this work so that coming out the top side of this storage towards the different servers that are going to be connecting into this machine, all they have to know is that they need to connect to the storage server and everything will be handled for them. This is exactly the same way that storage is handled in a storage area network, a hardware-based storage area network today. So now with all the storage taken care of here on the local side, the next step is to provision it out via iSCSI. I do have to show you one thing here, and that has to do with this one little requirement that's associated with implementing trim. We've already talked about the difference between fixed provisioning and thin provisioning, but I got to show you one commandlet here that just, I'm assuming that you have to know. That commandlet is, if we do GCM where name like, and I believe it's called optimize. That commandlet is optimize volume. There's a couple of them in here. Optimize volume, this optimize Windows image has to do with provisioning, but optimize volume is a command. It took me a while to actually dig to locate this new commandlet. I, to be honest, wasn't even aware that this commandlet existed. But if we look at optimize volume, and I do a get help on it, I can show you that the optimize volume commandlet has a lot of different options that are associated with it, not the least of which is to initiate a trim optimization on a volume that's been created. So once I've got that volume created, I can then tell it to go through and do that performance, whatever the work is that trim does, in order to keep those SSDs running at optimal performance. You can do some other things here too, to just analyze a volume, defrag a volume, to do some consolidation, and then to tier optimize a volume also. So optimize volume, a nifty little commandlet there. Also, I would keep aware of this optimize these optimized commandlets as they exist. I think there's even another commandlet called optimize VHD that exists when you've got a Hyper-V server. So a couple of optimized commandlets are useful for optimizing your storage, because that's one of the things we're talking about here in configuring and managing our storage. So with half of this task now completed, the other half of the process is for us to go about configuring the network-based access to the storage. So back to my original diagram here, where I now have this E drive set up. I now want to make this E drive available to other hosts on the network. Let's say I have a host here, and actually I'm going to use another host I'm going to use a little later on, CLUST1, which just so happens to be the first of the 3 machines we'll be using for a Windows cluster a little later on in this series. So let's assume that I got this E drive here, and I want to use iSCSI to be able to connect up file 1 to clust1 via iSCSI. There's a couple of pieces of vocabulary here that you'll get tripped up on for a long time until you just get it absolutely straight in your head. The 2 pieces of vocabulary you need to know are the difference between an iSCSI target and an iSCSI initiator. Sorry about my horrible writing today. The iSCSI target is what exists on the storage area network, and the iSCSI initiator is what exists on the host that is connecting to the storage area network. And like I said, you'll just get these confused forever, because keeping straight what's the target and what's the initiator is something I still get confused with, and I've been working with this thing for a long time. In a production world, it's actually possible to have multiple initiators connecting to multiple targets. So I might have multiple initiators up here and multiple targets that are connecting to multiple storage processors down here on the storage area network. But for our purposes here in this series, let's just focus instead on just a single connection between a host and its storage area network. That's the easiest of the connections here when it comes to iSCSI. Now we've got a couple of different things that we want to set up here, and there's actually a very specific process that you have to go through in order to expose these LUNs over the network. Now that I have the disk here, over here under iSCSI is where I then need to create an iSCSI virtual disk that will sit on top of this volume that I've created. This iSCSI virtual disk is literally a file that will be created and will sit on the E drive here that we will use as the location to store the contents that will be exposed through iSCSI. But here's the tricky part. There's a whole list of things that we have to set up here for iSCSI to function. But for us to be able to create the connection between the initiator and the target, I actually have to complete the process in what might be considered reverse order from what you're used to doing. So let's not create the virtual disk just yet, because before we create that virtual disk, let's go over here to our server. This is on the initiator side. The server that I want to plug into the storage area network, clust1.company.pri, and configure its iSCSI initiator first. Now, bear with me, because there's a reason why we're doing this in this order. Here under Tools, I want to come down here to iSCSI initiator, and if you've never clicked this before, it will tell you that the iSCSI initiator is currently disabled and needs to be turned on and then set to run as automatic. You want to do this because, well, every time you boot the machine, you want iSCSI to begin connecting this machine up to its storage. I'll click Yes here, and that will take the iSCSI process and set it to automatic, start the process, essentially get iSCSI up and running. And it's here where we get the world's least intuitive configuration interface. This interface is not changed in a multitude of Windows versions, and it's still just tough to figure out. The trick in your mind to helping you remember this little wizard here is start with the tab at the left and generally work your way to the right. That's how I remember it for myself. You got a couple of things here. The first is this quick connect dialog box that if I'm doing just a basic single connection, one initiator to one target, I can just simply plug in the target IP address into here, hit the quick connect button, and it will automatically locate that target server. Now, I don't want to show you that process because in all but the most basic of setups, this only sets up again, it's just a basic connection here. There's a single connection. Can't do any multipathing or anything on this connection. So let me show you the hard way to do this so that you can later appreciate the easier way to do it. Now, I told you that there's an initiator and there's a target. And in fact, let me go back to drawing this again because it's just easiest to remember. So this is the server, and this is file 1. And here is my iSCSI target, and here's my iSCSI initiator. And I'm now configuring this piece right here. The way in which I get the initiator pointed to the target is by pointing it at the target portal up here. This is going to be one or more IP addresses that are associated with the NIC, the network interface card, on this file server that I've dedicated to use for storage traffic. Now, I'm only using single NICs here just to keep this configuration simple. In a production world, you would separate out and have separate network on separate separate networks with separate network interface cards, all segregated out to protect your production networking from your storage network. But that's a conversation for an entirely different day. For us to make this connection, we want to come here and discover the portal on that server. Now, my server here, file 1, is, if I can just figure out what the IP address is for this server, the IP address for this server I've set up is 1.204. So I'm going to set up my IP address here as 192.168.1.204. I can come under here to advanced and then to set some of the additional configurations. These are fairly advanced configurations, but recognize that whenever you set up these settings, it's generally best to adjust these away from their default settings. Okay, I'm kind of getting here a little bit deeper than what's needed for the exam, but it's important for you to recognize that these settings are needed in order for you to have a best practices connection between your initiators and your targets. I'm going to set this first one to iSCSI initiator. I'm going to set the default initiator IP to the IP address on the local server that I want to use. If I want to set up authentication, I can do that. If I want to set up IPsec, I can do that as well. Choose OK and then OK, and this will go about making that initial connection, the discovery connection between the initiator and the target. Now, if I have this connection complete, we should, after a bit, be able to see some favorite targets here if they're available. But at this point, we don't have any targets that are set up because we haven't created any iSCSI virtual disks. I've only just started the process. To continue the process, I actually have to come back here onto my storage server and begin now to create the iSCSI virtual disk. I told you this is sort of backwards in the way this process goes. So I'm going to use this E drive that I've created, and I'm going to create a subfolder here called iSCSI virtual disk. We'll call this iSCSI LUN1, and you'll see that it's going to create a VHDX file in that location. So everything gets consolidated into a VHDX file. I'm going to use the full size of the drive, and I'll use dynamically expanding here so that I can ensure I don't fill up my storage space. Fixed size, as we talked about before, just gives you, essentially creates the entire disk or the entire file as the full size of the disk. Dynamically expanding gives me the ability to use thin provisioning. Choose next again, and it's here where we find out why we had to go through this process in such a ridiculous order. Because in order for us to make this connection, I have to identify the target and then associate the target with the initiators. If I click next here, I can create the target name and address, which I just, for ease of remembering, I just tend to create those with the same name. This target name can be different from the virtual disk name, and it may be depending on your naming standards for your environment. I'll choose next, and then identify the servers that should have access to this target. If I've done everything right, then I should see the initiator for clust1.company.pri here in the list of those in the initiator cache. I'm showing you this because you may feel compelled to manually type in this IQN value. This is the IQN address for that initiator in order to get it connected. But it's best to actually go through this process in the order that I showed you so that the initiator and the target are correctly configured. This item down here, although exists, doesn't always work in the way that you think it would. So start the process on the file server, continue the process over on the server you intend to connect, and then continue again the process over here on the file server. This will set up the connection between clust1.company.pri, this is the IQN address for that remote server, to my local file server here. I can set up authentication if I want. I'm not going to worry about that for now. And then click to create. So at this point, we have dealt with storage spaces. We have created all that beautiful storage tiering. We've got a nice pool of storage with a volume. Inside that volume, we have created an iSCSI virtual disk called iSCSI LUN1. That disk is only 4 megs in size because we've set it up as thin provisioning. And then now that we have this process complete, we conclude the process back over here under clust1 by making the final connection between the storage and the server. If I refresh things over here, I should now see that discovered target. So, again, a lot of steps here in this process. Still not done yet. With the target now in the list of those that are discovered, you can see that the target is currently set as inactive. I can set this now up as an active target. If I want to do multipath, again, a topic for another day, I can enable multipath here. I do want to set this up if I plan on having multiple connections to this target. And then lastly, I want to come down here and reset again the initiator and the target portal IP so that I have that best practices configuration between initiator and target. I'll click OK. And then I can come back through the list here, refresh again, see my list of favorite targets. Then over here, auto configure the volume, and I'm done. So I should actually, if I have this volume set up correctly, I think I have the volume set up correctly. I should then on this local machine be able to see the volume. Let's see. I'm going to open up disk management here, and what do you know? There's the volume that we have connected to on that remote server. Now, just like before, I've got to come here to the disk and then bring the disk online and then initialize the disk. And then once the disk is initialized, then I can come over here and create a volume. So you can imagine I'm creating volumes on top of volumes on top of volumes. There's my volume label, and poof. Once this thing is finished formatting, then the remote server will have the ability to access the local server, the local server, so that it can then begin to put content on that remote iSCSI volume. We'll be dealing more with this and some of these slightly more complex things when we start getting into clustering, because clustering has some additional special requirements, but these are the steps in order that you absolutely have to know for this exam, and you'll have to know also because you'll be creating iSCSI connections as well. I would be aware too of any time that I'm dealing with any of these, anytime I'm dealing with any of these iSCSI commands, I would be aware too, not here, over here, I would be aware too of the variety of iSCSI based PowerShell commandlets. So GCM, where, name, like, iSCSI here, and particularly just the mapping between these commands and the activities that we've done here in the GUI. So I'm getting a SCSI connection. I'm creating a new iSCSI target portal. I'm getting the server target. I'm creating a new target. I'm creating a new virtual disk. Just have a familiarity with the mapping between these and the actions that you've just seen. And that will probably help you out when it comes time to taking that exam. So we've got 2 more topics here that are perhaps better test questions than things you may actually find yourself using in production. The first of which is an ISNS server, and the second of which is this management of features on demand. I want to show you, because this is a certification-oriented series, I want to show you the certification-oriented bits for both of these, particularly with ISNS, because I don't think I've seen ISNS, at least the Windows ISNS, used pretty much in any environment so far. It may be out there, and I'm sure it is, but I just haven't seen it with my own 2 eyes, in part because ISNS is just, a lot of the storage admins out there are probably more interested in having some more manual configuration of their storage than the automated piece that this ISNS servers can provide. ISNS is literally a place where you register your targets and you register your initiators so that you can much more easily connect the two. Now let me go ahead and install the ISNS server service. And while we're taking care of the server service over here, I want to show you the location on the client side where you will point clients to your ISNS server so that they can register their initiators. If I come back here I'm back here on Clust 1. If I come back here to my iSCSI initiator, back here under Discovery, we've dealt with the target portals over here by manually assigning a target portal. But if I want to take advantage of some of this ISNS automation, I can just simply add in a server, the server IP address of the server running ISNS, into this location, and that will begin the process of registering my initiator with the ISNS service over here on the server. We've completed the installation over here on the server side, so let's take a look now at how the configuration actually works. Let me come here to Tools and ISNS Server, and you'll see that there's just not much here. Right? I've got the initiators and targets that have been registered. I've got one or more discovery domains that can be created, and then sets of those domains. Right out of the box, there will be a default discovery domain that's created here. And if I flip back over to my client side and then register my ISNS server with my ISNS server here, 192.168.1.204, that will add in this, I need to unblock the firewall. That will add in this initiator and register the initiator values, the initiator IP addresses and IQNs over with the ISNS server. So if I go back over here again, I should, I believe, end up seeing, there it is. There's the IQN name for that initiator that has been registered. In fact, there it is right there. I can then view the details of that here from this location if I want. But you'll notice that in order for me to see anything else other than initiators, well, wait a minute, where are my targets? Well, in order for the targets to get registered, I've got to do a little bit of hackery here into WMI. And it's a fairly complex command. So set WMI instance, namespace, root WMI, class, WT underscore ISNS server, arguments, and then create this at server name equals, and then the ISNS server name, which will be file1.company.pri. I think that's in FQDN format. And then there. That ends up creating enabling the registration of targets. So I believe now, hopefully, once we complete this process, we should be able to register ourselves, and there we go. Now see the targets that are associated with this ISNS server. So again, it's kind of like a DHCP server here for all the targets and all the initiators that exist out in our environment, but this gives you the ability to identify what is out there. Got one final topic here, and I will freely admit this is one topic I'm going to kind of punt on because it's a kind of a silly topic here, but you should be aware of what it is. And that is the recognition that Windows Server installs or has the ability to install features on demand. When you install a feature to Windows Server, the bits for that feature have to come from somewhere. And in environments where you're particularly constrained for space, you may not want to have those features directly available. And so there is the ability to create alternative locations where those features can actually get their installation bits from. When you attempt to install a feature, that feature is going to come, the bits for that feature are going to come from one of three possible locations. The add roles, whatever the configuration is in the add roles and features wizard. There's a group policy setting that lets you define a additional location, like a repository of all of this content. Or you can just download the information from Windows Update. The problem is that Windows Update, as the last option, can take an inordinately long amount of time for the download to complete. And in air-gapped environments, those that aren't connected to the internet, you might have to have, or you won't have access to Windows Update in order to get those things. So you have a couple of options here to override the default behavior by specifying an alternate source path as part of the PowerShell commandlet that you run, By doing so on the Confirm Installation Options page in the Add Roles and Features wizard, or by setting up a group policy that defines that alternative location, which more or less is a feature or side-by-side store. It's literally just a share where you copy the contents of sources/sxs from your Windows folder installation media to the shared folder, and then point your install to that location. The only other piece you should be aware of when it comes to Windows features on demand is the fact that when you use uninstall Windows feature, you can use the -remove switch to actually remove the content off your server so that it doesn't exist there just waiting for the potential future reinstallation of that content. Again, test questions. Do you see this in the real, the production world? Not all that often, except in the occasional air-gapped environment. So what have we talked about this nugget? We've gone through the somewhat complex process of configuring the storage backend and then also kind of the storage front end for our file server. On the back end, we configured some tiered storage, very small tier storage, but enough so that we could see the process of starting with storage directly connected, creating storage pools, creating virtual disks, creating volumes, enabling data deduplication, dealing with thin provisioning and trim, and getting everything prepared so that we could make an iSCSI connection out to some other server out on our network. Then with that in place, we took a look at a couple of the minor topics here that are ISNS, and then managing those features on demand for environments that may be air-gapped from the internet, or in cases where you just want to scrub from your servers any features that don't exist on those servers. Coming up next is a continuation of our exploration into file servers and file services. In this next nugget, we're going to talk about some advanced file services. And these are things like branch cache and NFS and file auditing. Really just a couple of minor topics here that you can lay over the top of what we've created here on our file server for the purposes of serving out additional content, either caching it via branch cache or making it available through alternative protocols like NFS. That's a topic for our next nugget, so until then, I hope this has been informative for you, and I'd like to thank you for viewing.